In the world of DNA sequencing, we often have a high confidence reference genome, and when we do a sequencing experiment, we obtain a bunch of short sequences known as reads, and we want to find where those reads likely occur in the reference genome. So we can think of this as a computational problem where we have some database that's a single long string. This would be, for example, the human genome, and this database doesn't really change. But then every experiment, we generate this massive set of query sequences where each of these sequences is short, but we could have millions of these sequences. And we want to find where every single one of these queries appears in my database string. So this looks similar to the problem that we solved using an aho-Karasik automaton, but the problem here is that we've kind of flipped the roles between our set of short sequences and our long sequence. With the aho-Karasik automaton, we had a fixed database of short sequences, so the database of short sequences would not really change, but we would have different queries that we wanted to match to this fixed database. But in this example, we flipped these roles. Now, the reference sequence, that long single sequence, is unchanging, but every single experiment will have a completely different set of short sequences. And then again, we want to find all instances of every single one of these strings as they appear in this reference sequence. So let's assume that our database sequence is length n. So for the human genome, this would be roughly 3 billion. And then our query sequences, so in the DNA sequencing world, these would be reads. Let's imagine we have m short sequences. Each one of them is length k. And we can assume n is much bigger than k. In the world of DNA sequencing, k is usually roughly 100 to 150, and m would be, millions, or even potentially tens or hundreds of millions. So a lot of sequences, each length 100, and n is usually roughly 3 billion. And again, this set of sequences changes frequently. So how can I somehow find matches of every single one of these in this database sequence? As we saw with the aho-Karasik automaton, the trivial solution of just doing a linear scan across this database for each one of these queries would be extremely, extremely slow. Specifically, the simple linear scan, so what does that mean? For each query sequence, do a linear scan of my database, checking if the current substring matches that specific query sequence. So the linear scan would be big O of n for all the potential start sites, times k for the actual big O of k equality check, times m, because I would have to do this for every single sequence in my query. This is way too slow. So how can we speed this up? Well, with the aho-Karasik automaton, because our database was a database of short sequences, we pre-processed our database, knowing that it's not expecting to change very frequently. And then we were able to speed up our query scans on that pre-processed database. In this problem, the roles are reversed. The database is my long single sequence, but that mentality still holds. Can I somehow pre-process my database sequence, the reference genome, to enable much faster searches of each of these query sequences?